Okay, let's slide up and take a look at the second requirement and the third one. All right, requirement 2 says Chew anticipates 2,600 machine hours and 300 batches for next month. Using the cost driver you chose in requirement 1, what amount of support overhead costs should we budget? Okay, so 2,600 or 300. We'll go back here to we had our graphs, and I'm going to slide a little bit, and we're going to choose batches. All right, so we know we're going to have a fixed cost of 16,031, right? And that comes from that right above my mouse there represents that portion of cost we expect to have regardless of the level of activity, or another way of saying that is that portion of costs that are not explained by the batches, right? Not explained by the variable cost. I hope you all understand that where it crosses the y-axis represent fixed costs, and then the slope of the line represents the increase in cost per every unit of activity. So we've got 16,031 is our fixed cost. We've got 197.3 as our cost per batch, and this problem anticipated that we were going to do 300 batches, right? 300 batches. So we'll jot in the $300, and then I'll just program that formula, which is equal to the 16,031 plus, I'll put a paren around this parenthesis so we know, 197.30 per batch times 300 batches, and that should be a prediction of the cost we'd anticipate. And taking away the decimal places, it comes out to be $75,221. And I'll bold that to show that that's the answer to part 2. All right, now let's look at part 3. Part 3 says, assume the facts in requirement 2, and Chew adds another 20% to the cost to determine target revenues and hence prices. Costs other than support overhead are expected to equal $125,000 next month. Compare the target revenue numbers obtained if the cost driver is machine hours or number of batches, and what would happen if Chew chose the cost driver you did not choose in requirement 1 to set target revenues and prices. Describe any other implications of choosing the other cost drivers and cost functions. Okay, now I've staged this a little bit just to save some time on the demo. What I've done is I've added some titles that let us know what the columns would be that we could use to solve this. All right, first off, we're taking a look at the budgeted revenue and cost for next month, and we're going to base it on using batches as the cost driver or machine hours as the cost driver. Okay, now in this case we used batches to derive what an estimated cost would be, and then they also asked us what would it be if we used machine hours. Okay, well, let's now on part 3 tackle the machine hours, and I think machine hours, they said, let me go back here. The machine hours was going to be 2,600. So if we use the 2,600, we would have, let me slide back up, our machine hours was 28,089. So we'll enter that. And the variable cost then I think was $10, and we'll round that to 23 cents per machine hour. And they were expecting 2,600, so if we enter that in, we can simply copy this formula. All right, and there we get the anticipated cost if we used the other cost driver, and it would be $54,687. Okay, now I'm going to unbold that because that really wasn't the answer to part 2, but we need it to work on part 3. And let me just add another row here to separate it, because now as we work on part 3, we've got to add in what they're predicting would be the cost other than support costs, and that was $125,000. Okay, we'll add that to both sides, right, under both scenarios. Support overhead costs are the predictions that we used in part 2. So if we use batches, it would come from the 75,221. right? At this point, I want to turn all of these, format it that way. And if we use machine hours, our prediction of overhead costs was going to be 54,687. Okay, so total cost we would just sum from above, right? So we get 200,000 under one scenario and 179,687 under the other. 200,221 to be exact. And then we would add in a 20% margin of total cost. So if we take that times 20%, the 200,000 times the 20%, we come up with 40,044. Okay, and we take the total cost plus the margin we anticipate, and we would come up with what the target revenues would be. And now I will format this one like that one, and maybe add a double underline underneath. And my lines aren't perfect, but I think you get the gist here. And then we can copy that over, and we should wind up with the right formulas as well, because we're taking the total cost times 20%, and then of course taking the total cost and adding in the margin, and we come up with the answer we were looking for in part 3. Okay, then it says, describe implications of choosing the other one that you came up with. Well, if we pick machine hours rather than number of batches, we think what we see here is that we would underestimate cost, right? 215 versus 240. And we would also wind up with lower target revenues and possibly lower prices. So here we see why it's critical to choose the right cost driver in terms of pricing decisions. Target profitability may not be met if we choose the wrong cost driver. So we want to use the best one we can. Okay, and it also could have some repercussions for cost management. If we budgeted support cost at 54,687, which is that number there for machine cost, and then we do the regression, there's a good chance we may actually see that support cost would come out at 75,000. So again, we've got some implications to cost management as well. Alright, so what's the big point here? Using wrong cost drivers can mislead management in terms of cost planning, cost management, cost control, and it could lead to making inappropriate product pricing decisions. So it's real key that we evaluate the data as best we can and use that to make good decisions to help maximize the long-term profits of the products and services that our businesses sell. All right, that takes care of this problem, everyone. Thank you.